Okay, grade 11s, we are still doing analytical geometry. In the previous video, we looked at the application of distance of a line, and now we're going to look at midpoint gradient and equation of a line. We're going to briefly go over these first two because they're very important to do in figuring out the equation of a line formula. And we're going to fill in something in these two blocks over here. Okay, let's get straight into it. The midpoint formula. The midpoint formula we normally call M. It's equal to x1 plus x2 over 2 and y1 plus y2 over 2. It doesn't matter if you said x2 plus x1 and y1 plus x2. This is simply an average formula. Right, so we have our little triangle. Given the points A, B, and C, determine the coordinates of P if P is the midpoint of BC. So we have the line BC. Now remember this is an average. So if we had to draw a line here, and we have a line here, oops, and we took these two values, so we have our x values, right? And we said this value plus this value divided by 2 will give us that. And that value plus that value divided by 2 will give us that. And we can simply figure out a line and find where our P is. And this is an average. This is your midpoint formula. So there we have P. Taking C as x1, y1 and B as x2, y2, so we have x1, y1 and x2, y2, P is equal to negative 3 plus 4, right? So negative 3 plus 4 over 2, that's the coordinates, and 4 plus negative 5 over 2, right? And that is equal to a half and a negative half. See, there's a negative half. And that is the coordinate of P. Now, the midpoint can be seen as the average of both the coordinates. You know how to work out an average, and that is exactly what the midpoint is. Let's move swiftly on to gradients. Gradients is M is equal to, now this is a small m that we often denote as gradients, and this is y2 minus y1 over x2 minus x1. It is very important here that the numbers 2 and 2 and 1 are in the correct order, right? So this formula is also used in the perpendicular lines and parallel lines section. We're not going to get into that right now. And then there's also this M is equal to tan theta, but we're going to talk about this mainly in inclination of a line section. And we'll discuss more about it in that video. So let's look at our Cartesian plane. We have our line, and we have points on the line A and B. A is negative 4 and 5, and B is 6 and negative 4. Determine the gradient of the line. Okay, how are we going to figure out the gradient? Now, let's take these points x1 and y1, like we've done here, x1, y1, x2, y2. Right? Let's put them into this gradient formula. Okay, let us continue. So we have y2 minus y1. What is y2? y2 is negative 4. Minus y1 is 5. Negative 4 minus 5. Then we're going to have x2 minus x1. 6, which is x2, minus 4, right? So we're going to simplify that. It's negative 9 over 10. So the gradient is negative 9 over 10. What does this mean? It's negative. A line going this way is negative. And what it is, it's saying for every negative 9 we go in the y, so for every 9 points we go down in y, so we've gone down 9 here, so that's negative 9. For every 9, this line goes 10 across in the positive x. Okay. The gradient of a line is important in finding the equation of a line, as we discussed, as it determines the slope of the line and the x-intercept of the line. Okay, we're going to talk more about this in the next couple of slides. Let's look at the equation of the line y equals mx plus c. This is the equation of a line. It will never ever change. Make sure you remember that. We have a Cartesian plane. To find the equation of the line, you need to have the gradient of the line, remember that's little m, and a point on the line with x and y intercepts on the line, or the x and y intercepts. So a negative gradient, this is m is less than 0, so in other words, m is negative, will give the line that slopes down to the right, right? And a positive gradient, where m is greater than 0, will give a line that slopes down to the left, like that one here. So the c value is the y-intercept of the graph. C is where the line crosses the y point on the graph. Okay. Let's have a look at the equation of a line. Given the equation of the line CD as y equals 5 over 6x plus 3, determine the x and y intercepts of the graph as well as the gradient of the line. Okay, the gradient of the line is easy as it is just the m value in the equation y equals mx plus c, right? So what does that mean? The gradient is simply that, right? So the gradient m is equal to 5 over 6. That means for every 5 points we go up, 5, we're going to go 6 across. Let me draw that better. So 5, we're going to go 6 across, right? To find the x-intercept, we need to make y 0, right? So this is a simultaneous equation. Where does the line cross x? It crosses x where y is equal to 0. So this we need to find. So we simply make y is equal to 0, and then I'm not going to do it for you. You can solve x to find it's negative 3.6. You simply move the 3 there and multiply it, right? So this is here, negative 3.6. To find the y-intercept, we need to make x is 0. That's because on this line here, x is equal to 0 over here. So we can figure out what this y is. So we make x is equal to 0, and then we can simply see that y is equal to 3. Okay, let's have a look at this continuum plane in this example. Now we are given 2 points, A and B. So now we need to determine the equation of the line. Ooh, this is quite easy because we got our formula y equals mx plus c. Right, so let's first start by solving m. And we know that is y2 minus y1 all over x2 minus x1. What is y2? Negative 5 minus minus 5. And then 4 minus minus 3. Simplify that, negative 10 over 7. So this means for every 10 we go down, we go 7 across. Right, so every 10 we go down, we go 7 across. So we can have our equation, we can update it. Y is equal to negative 10 over 7x plus c. But we still don't have a value for c. But that's okay, because what we can do is we could just sub in a, because we know an x and y value. So we put that x and y value into our equation, or rather put that into our equation. So we say y is equal to 5, x is equal to negative 3. We can sum that out to get c is equal to 5 over 7, and you can work that out pretty easily. And then we can update, so this c value is simply saying that this over here is 5 over 7. Well, x is 0, so in the coordinates is 0 and 5 over 7. So we have our equation of a line. Y is equal to negative 10 over 7x plus 5 over 7. Let's have a look at another example. Lines AB and CD intersect at 90 degrees at point P, right? We're given point P. Given that the gradient of CD is 7 over 5, the gradient of CD, so we're going, for every 7 we go up, we go 5 across, so 7 over 5. Determine the equation of the line AB and CD. So we've got to determine these two equations, right? The gradient of the line CD is given, so all we need to do is sub in point P, right? So we know we got our line equation, and we know the gradient of M, right? Of line CD. So we know that that's gradient. So we say y is 7 over 5x. Now we need to solve C, so we sub in our x and our y, because we know P is on that line. So we sub in P as a half and negative 2, and we get y is equal to negative 2, and P is equal to a half, and do this yourself, but you'll get that C is equal to negative 2.7, right, which makes a bit of sense. What line are we dealing with? We're dealing with CD, and we're saying that's negative 2.7, which makes sense as it's less than 2, right? And then we're getting the equation of our line, y is equal to 7 over 5 minus 2 over 7. Perfect. Okay, let us now find the next line. Since AB is perpendicular to CD, we can use the formula M1 times M2 is equal to negative 1. If you're not understanding how we did this, make sure you watch the video on that. This is to find the gradient of AB because we know that they're perpendicular. Remember, they're right angled. There's 90 degrees intersection. So MAB times MCD is equal to -1. So we can say MCD, we know that as 7 over 5. So we can simply calculate MAB is equal to -5 over 7. Remember, we switch that around when we take it to the other side. So we got our equation so far that y is equal to -5 over 7x plus c. Again, we need to solve c. What do we do to solve c? We put in our p, a half over -2, like we've just done. -2, our half. And then we can solve c is equal to -23 over 14. This is just a bit bigger than, -2, so it's just around there, and you can see it works. And then we have y is equal to -5 over 7 minus 23 over 14. And that is our equation of our second line. You can see that these gradients are perpendicular to each other. Okay, well done, grade 11s. This was our section on midpoints, right? And we had the formula where m is equal to x1 plus x2 over 2, y1 plus y2 over 2. Remember, this is our average. Each of these are average. Then we looked at our gradient. Now we had two gradients. We're not touching on this because we're going to get into it there. But we knew that this gradient we can use for finding the formula for a line. And then the equation of a line formula, you've got to remember y equals mx plus c. Well done, grade 11s. Let us continue to inclination of a line.